So in a prior video, I tried to discuss representations in an algebra forms using complex numbers, where you use something like a J symbol to represent what mathematicians normally think of as I, which is rotating your frame of reference in a certain sense as an operation. In that context, up triangle of J gives you a point in the upper half plane, minus 1/2 plus 1/2 J. Down triangle of J is the reflection of that in the x-axis. And then there's some kind of symmetry between J and minus J, as it were, in terms of that representation. So I'm going to talk about split complex numbers. And so here, if you have 1, minus 1, I, and minus I, the triangle function operates very similarly, except your points are located on the positive 1/2 line instead of the negative 1/2 line. And you can look it up on Wikipedia, split complex numbers. These points are interesting because, well, for 1, let's define it a little bit better. It's 1 plus I over 2. That's also equal to down triangle of negative I. And then down triangle of I is equal to 1 plus negative I over 2, which is equal to up triangle of negative I. Okay, so some interesting things happen. I guess, well, I down triangle times I, right, ends up being, it's equal to the negative of itself. But up triangle of I times I, the I in the triangle times I, is equal to itself. It's idempotent, so it squares equal to itself, and in fact, if you put it inside of the triangle function, it is also equal to itself. So what's really interesting about this is that the square root of I is a very interesting thing. It can be represented in either a basis using up and down triangle of I, or up and down triangle of J, modified by either I and negative I or J and negative J. But it ends up being something with a really cool kind of symmetry, where you have 8 points, sort of something like a square type symmetry in a way, and your simple operations allow you to rotate between those points. So the square root of I times J is 1 over the square root of minus I. You can multiply again to get to negative square root of I, or multiply again by J to get to negative 1 over the square root of negative I. But this forms a really interesting basis. It has some relationship to the tesserines, which you can also check out on Wikipedia, although it doesn't really look like them in a lot of ways. But something else that I thought was interesting, so I think we use split complex numbers all the time, particularly in physics, but we don't tend to know that we do. Anytime you have e to the x equals cosh x plus sinh x, you could always add an e to the I x, and then this is an I sinh term. So it's something that's commonly used, but perhaps not consistently represented in mathematical notation across disciplines.